Hello everyone, as you can see on the slide, our topic for today is heating device. In this presentation, we will focus on about the importance of theory of thermodynamics in heating device. Before we go further, let me introduce myself and my group member. Our group consists of 5 members. Let me start first. My name is Indah Sakina binti Shamudin, and the rest of member is Siti Nuzlaika binti Nur Azlan, Aisyah Sofia binti Nur Zaini, Siti Nur Fazlin Farhana binti Muhammad Raza, and Siti Nur Alia binti Sharifuddin. What is the meaning of heat? Heat is a form of energy that is transferred between system or object with varying temperature. The unit of heat is joule. The transfer of heat can generally occur in 3 ways. The first one is conduction. Conduction is where heat is transferred through a solid. The second one is convection. Convection where heat is transferred through a fluid, for example, liquid or gas. The last one is radiation, where heat is transferred through empty space. Here are some examples of heat. The first example is when a metal spoon is put into a hot soup. After a while, the spoon also becomes hot. This is an example of heat conduction. The second example is in a boiling pot of water, the water at the bottom gets heated first. This hot water rises to the top, allowing the cooler water to sink to the bottom and get heated. This whole process is an example of heat convection. For your information, a key understanding in thermodynamics is the concept of heat flow. Heat will naturally flow from systems with a higher temperature to those with a lower temperature. What is a heating device? Let me tell you guys the definition of it. Heating device is an instrument designed to produce heat for a room or inside area and includes a non-electric stove, fireplace, freestanding stove, or space heater. For example, oven, hot plates, heating mantles, tapes, oil bath, salt bath, sand bath, and so on. There are so many examples for heating device that we use in our daily life.
Next, I will be talking about the essential rules and applications of heat in the field of thermodynamics. Thermodynamics is typically defined in terms of quantities like heat, work, and internal energy. Understanding heat is crucial as it allows engineers to design efficient systems and processes. First, let's explore the fundamental rules and rules of heat. I will give 2 examples. First, energy transfer. Heat is a form of energy that can be transferred from one body to another, affecting the temperature and phase of substance. Second, thermodynamics. Heat plays a central role in the study of thermodynamics, which deals with the relationship between heat, work, and energy. Now, let's look at some specific applications of heat in thermodynamics. First, designing and optimizing heating systems in buildings. Second, creating efficient engines and power generation systems. Heat is crucial in the operation of engines and power plants. For instance, internal combustion engines convert heat from fuel combustion into mechanical work. In power plants, heat generated from various sources such as fossil fuels or nuclear reactions is used to produce electricity. And the last one is improving cooling systems in electronic devices. Heat management is vital in electronic devices to prevent overheating and ensure reliable operation. Engineers design advanced cooling systems to dissipate heat effectively from components. Next, this is the formula of heat. Q equal to mc/T. Next, I'm gonna discuss the various types of electric heaters commonly used in homes. We will categorize these heaters into 2 main types: convection heaters and radiant heaters. Convection heaters warm the air in the room by circulating air. These heaters work by heating the air that passes over a heating element, causing the warm air to rise and circulate throughout the room. Common types of convection heaters include baseboard heaters and central heater systems. And for the radiant heaters on the other hand emit infrared radiation that directly hits objects and people in their path rather than warming the air. These heaters provide instant heat and are often used for spot heating. Examples of radiant heaters include infrared heaters and space heaters. So the common types of electric heaters, which are baseboard heater, space heater, infrared heater, and central heating. As you guys can see, these are images of different types of heaters, this is a baseboard heater, space heaters, infrared heater, and central heating. And I will pass to next person.
Next, from this topic, we analyze that we got so many types of heating device. First type is boilers. Boilers is used to convert chemical energy in fuels to thermal energy. Second type is heat pumps. Heat pump is transfer heat from a cooler area to a warmer area using mechanical work. Third type is electrical heater. Electrical heater is used to convert electrical energy directly into thermal energy. Fourth types is solar heaters. Solar heaters is used to solar energy to heat fluids or air. From the second analysis in heating device, we got that we have two laws in thermodynamics. First law of thermodynamics is energy conservation. Formula for the energy conservation is U equal to Q minus W, where U is the change in internal energy, Q is the heat added to the system, and W is the work done by the system. For the second law of thermodynamics is entropy, which heat flows spontaneously from hot to cool, then the efficiency of heat engines and heat pumps is limited by the Carnot efficiency.
The coefficient and performance metric, which is explained coefficient of performance (COP) for heat pump. COP heating equal to QH over W, where QH is heat delivered to the hot reservoir and W is work input. Then thermal efficiency for boilers and heaters, which is N equal to Q in over Q out. Q out is useful heat output and Q in is the input from fuel. Last analysis is heat transfer mechanism. There are three types of mechanism. First, conduction, there is heat transfer through material. Second, convection, heat transfer through fluid motion. Third, radiation, heat transfer through electromagnetic wave.
However, there must be advantages and also disadvantages of the usage of heating devices. So let's go to advantages first. The first one is efficiency of heat transfer. So efficient heating appliances are like the superheroes of thermal energy. They can efficiently the substance and also system, while ensuring we can control the temperature change exactly as we need it. This not only saves energy but also helps to maintain a comfortable or optimized environment in home and or industry alike. The second advantage is regulation of temperature. So imagine a world when room temperature is always just right, whether it's for your cozy living room or for complex industrial process. Heating devices excel in regulating temperature precisely, ensuring that fluids are maintained at ideal condition for various industrial process. This level of control is key for optimizing efficiency and ensuring consistent performance across the different systems. The third advantage that we share is versatility in heating appliances. So heating appliances are true chameleons. They are very in shapes and sizes, from compact units for small rooms to powerful systems that cater to expansive industrial spaces. Whether powered by electricity, gas, or oil, they are designed to handle a wide range of fluids, temperature, and flow rates. This adaptability makes them indispensable across diverse applications, providing tailored solutions and also whenever the heat transfer needed. So what can I say about the advantages is basically efficient heat transfer and versatile heating appliances are not just for staying warm. They are about optimizing the energy use, maintaining precise condition, and also adapting to diverse needs. By harnessing these technologies, we can create environments that are both comfortable and efficient, whether at home, in office, or on factory floor. Okay, so then next we go to disadvantages. Okay, for this I will share 3 disadvantages of heating devices. The first one is high energy consumption. So we're tackling an important aspect of heating appliance, the energy consumption. Heating appliances are notorious for consuming significant amounts of energy, especially in areas where electricity or fuel costs are high. So this not only results in higher utility bills but also increases the environmental impact. Air conditioners, for instance, can dramatically increase energy consumption when used frequently, requiring both mechanical power and also electricity to operate. So the second disadvantage is initial cost and also installation. In areas with expensive fuels or electricity, heating appliances can drive up utility costs and have a substantial environmental footprint. Air conditioner known for high electricity consumption during regulation uses contribute significantly to this cost, varying by location. Moreover, for homes and business, the upfront investment in purchasing and installing efficiency heating system can sometimes be perceived as costly. So the third disadvantage is maintenance matters. Okay, now on to maintenance, a crucial aspect often overlooked. Over time, heating appliances accumulate dirt such as organic waste or scale on the surface, leading to fouling. This build-up can increase internal pressure and reduce heat transfer efficiency. So regular cleaning and maintenance by trained professionals are essential to keep this system operating smoothly and safely. Neglecting maintenance not only impacts performance but also poses safety risks for the users. So while heating appliances play a vital role in our comfort productivity, they also pose challenges related to energy consumption and its initial cost and maintenance. So by investing in energy efficient technologies, adopting responsible usage practices, and prioritizing regular maintenance, we can mitigate these challenges and move toward a more sustainable future. So next, so it comes to the end, so let's wrap up by talking about the role of heating system in Malaysia. These devices are crucial for providing comfort and warmth, especially in cold highlands and during rainy monsoon months. They truly make indoor life more enjoyable and cozy amidst varying weather conditions across the country. It is important to take note that benefit of humidifier as well. They promote better health, reducing breathing issues, and enhance overall quality of life. However, it's also crucial to recognize the environmental impact due to high energy consumption. So in conclusion, heating system plays a vital role in ensuring comfort and health in diverse tropical region of Malaysia, yet we embrace their benefits. It's equally important to consider their efficient use and the responsible consumption of energy for a sustainable future. By making mindful choices and adopting energy efficient practice, we can enjoy the comfort of heating systems while safeguarding our environment. So thank you for exploring this topic with me today. So remember, whether it's staying warm in highlands or managing humidity indoors, our choices today shape the world of tomorrow. Let's strive for balance where comfort meets sustainability. Thank you.